Good day guys, let's do some more partial fractions. Our starting point is the same. We check the degree of the numerator. Here is 2. Denominator, if you multiply x squared by x, it gives you 3x cubed. So degree of numerator is smaller than denominator. That immediately tells me that there is no need for partial fractions. So there is no need for long division, so I'm going straight to my partial fractions. So that's my fraction, x squared plus 5 into x minus 3. So looking at this, you can see that the denominator is the one that helps you know how to choose your partial fractions. So if you have a denominator that has a quadratic that cannot be factorized, you see this quadratic, you can't factorize more than this, then there is a way of writing your partial fractions, which if you are an NC student using your formula sheet, it can guide you to know how to write it, and I'll try to write it the way they will do with the formula sheet. You get ax plus f divided by the quadratic, but you can also call it ax plus b, it doesn't matter, it's just a constant. I'm just trying to make sure that if you're using your formula sheet, you can see from there so that it guides you to write your partial fractions with ease. But if you're not using the formula sheet, this can be ax plus b, then you get c on the linear. So that will be our partial fractions. Then we'll start the procedure of getting our a and b. So we'll get our x squared minus 5x plus 4, and I hope you know how we got that. This is the LCD. If you divide it by itself, it's 1, you multiply there, you get there. Then if you take LCD, divide here, x squared plus 5 will cancel itself, and left with x minus 3 into ax plus f. Then plus, if I take this and divide there, x minus 3 will take care of itself. Then I'm left with b into x squared plus 5. So that is where we get up to so far. So whenever I'm doing partial fractions, in the case where there is a quadratic involved that cannot simplify, my own fastest way of getting to a, b, and f is to choose a number first. You see there are 3 constants. If you want to choose 3 numbers, it's fine. If you want to expand everything and compare coefficients, create 3 equations and solve, is fine. But my advice is always that in this case where there is a quadratic that cannot factorize, choose one number which comes from the linear, you equate that to 0, you substitute, you will get one of the solutions. Then after you expand, when you compare coefficient, you get the rest. So if I'm choosing a number, I'll be saying let x be equal to 3. I got 3 by equating the linear factor to 0, solve for x. Then I substitute it right across. If I put 3 here, that is a 9. 9 plus 4 is 13. 13 minus 15, since 5 times that is 15, I'll get negative 2. And now since 3 came from x minus 3, it means this item will be 0, because if you put 3 here, that will be 0. Then you put 3 here, 3 squared is 9, 9 plus 5 is 14b. So from here, you see that we have arrived at b so fast. So our b is negative 2 over 14, or negative 1 over 7. So that's how we got to b. So now to get a and f, I will not be choosing numbers, because if you equate this quadratic to 0, you cannot solve for those 2 values. That will be complex, and that will be a problem. And I can't choose other numbers that will take me too long. So what I will simply do is I will go for expansion and compare coefficient. So that's my own way of doing it fast. So if I multiply, I'll get ax squared. Then I multiply there, I get 3ax. Then I multiply this, I get my fx. I multiply this, I get 3f. I multiply that, gives me bx squared plus 5b. Then I can compare coefficient. Keeping in mind that I'm done with b, so when I'm comparing coefficient, I'm targeting where there is a and f. So I will need the coefficient of x squared, because you see there is a there. Coefficient of x squared. On the left, I've got a 1. On the right, I've got an a, and I've got a b. But now you remember, b is negative 1 over 7. So if you put 1 is equal to a minus 1 over 7, you see 1 over 7 is a friend to 1, because they are like terms, which if it crosses over, it will add up 1 over 7 plus give us 8/7 for our A. So now we are done with A and we are done with B. What we are left with is F. So I can also verify where there is F. I see coefficient of X has F. I see the constant also have F. I think I would prefer to go to coefficient of X because those 5, B and 3, they might take me long to solve. So I'll look for coefficient of X. On the left, I get a -5. On the right, I've got a -3A plus an F in front of X. So my A, what are you? 8/7. So if you multiply that, you get -5 is equal to -3 times 8 is -24/7, then plus F. So if I need F, what do? I simply carry 24/7 to the other side and subtract 5 from it. So I will take 24/7 minus 5. It tells me that F is -11/7. So my F is -11/7. So now I'm done with the values of A, of B, and of F. So it's now time to do integration. So when I'm doing integration, I will just go back to the original problem, copy it from left to right, and then replace A, B, and F. So the integral of x squared minus 5x plus 4 on x squared plus 5 into x minus 3 will be equal to, when I'm copying that, I will then replace my A is 8/7. So it will be the integral of 8/7x, my F, my -11/7, all this divided by the quadratic, x squared plus 5 dx. Then the other item is B, which is -1/7, so it's the integral of -1/7 on x minus 3 dx. So that is what I have to integrate. And the starting point for me, it's always this formula for use substitution for a fraction. This is a formula that once we are doing partial fractions, there is no way you won't use it. Because you see, it's the formula for integrating a fraction. So I usually start by testing this formula to see what I have to do. So if I look at this formula, for the first item, you see that if I take my 1/7 outside, for the second item, I will get -1/7. The integral of 1 on x minus 3, since I've said we must practice taking out the constant. So if I verify this formula here, you see it's a perfect match because the derivative of x minus 3 is 1. So this formula is a perfect match for that one after I've taken out the constant. But if I go here, derivative of x squared plus 5 is supposed to be 2x. So when you see that item there is not 2x. So in this situation where you are dealing with a partial fraction that has a quadratic there and the derivative is not matching, if that was 2x, then it would be a perfect match for this formula. But if it is not matching, you have 2 terms instead of the one you need. The advice is to split to become 2 integrals, where your first integral means you take this on x squared plus 5, the second is this item on x squared plus 5, and when writing it, please practice taking constant outside. So I will take my 8/7 out and write the integral of x on x squared plus 5 dx. That's my first integral. Then the second one is -11/7, the integral of 1 on x squared plus 5 dx. So that is what we should do each time we find a quadratic which is not accepting our special formula for partial fractions. So you have to split it like that. And once it is split like that, between the 2 items, one of them must accept that formula, after some adjustment, of course. So if you look at this, you see that when you differentiate x squared plus 5, you create 2x. So the fact that x is already there tells me that it's possible to do that, to involve that formula. So we will now try to invoke the formula for use substitution there. We just copy x squared plus 5 there. We do what the formula wants. Any function here, its derivative must be up. So when I differentiate x squared plus 5, I get 2x dx. Then to make sure that I've not change the original problem and compare the two. You see they are no longer the same because there is a 2 here that does not appear here. So you need a number outside to balance that up, and that should be an half. So that way, you've done your use substitution with the help of understanding that formula on page 4 of the formula sheet. Now, in the other one, whenever you split this to quadratic to form two integrals, as I've told you, one of them must accept that formula. The other one will be taking you to another formula on page 4 of your formula sheet, which we did it when we were doing completing the square. So it should be taking you there, which will give you 1 over AB, the arctan of bx over a plus c. So as an N6 student, there is a formula like that on your formula sheet. So all you need to do is to rearrange this problem to match that formula. So if I do my rearrangement, I see that this formula, the constant comes first. So it will be 1 over 5 plus x squared dx, then minus 1 over 7, the integral of 1 over x minus 3 dx. So this is a perfect match for this, which means I'll be saying that if I match this to that, my a squared is a 5, so that means a is on 5, and my b, since there is no number here, I can put a 1 there, my b squared will be 1, that means b will also be 1. Then x stays x, then I can now write down my answers. So my final answer, 8 divided by 2 is 4, so we'll get 4 over 7, the mean of x squared plus 5 for the first, because the first is a perfect match for this use substitution formula for the fractions. Then minus 11 over 7 into, to write the answer of this, we're going to use the left side. We need 1 over AB. If a squared is 5, it means a is root 5. B squared is 1, it means b is 1. So we'll have 1 over the square root of 5. Then the arctan of b is root 5. Then times x. So that is what we've got there. Then minus 1 over 7, the link of x minus 3 plus c, since this one is a perfect match for our first formula. So guys, thank you very much. That's how you handle this kind of partial fractions.